Hello everyone. This is a problem from quantum mechanics which is asked in JEST 2019 exam. The question is the wave function psi of x which is equal to a e raised to minus b square x square by 2 for real constant a and b is a normalized eigenfunction of the Schrodinger equation for a particle of mass m and energy E in one-dimensional potential V of x such that V of x equal to 0 at x equal to 0. Which of the following is correct? 4 options are given. The first option is V is equal to h bar square b raised to 4 x square by m. Option B is V is equal to h bar square b raised to 4 x square by 2m. Option C, the energy eigenvalue E is equal to h bar square b square by 4m. Option C and D, the energy eigenvalues are given. And option D, E is equal to h bar square b square by m. We can solve this in two ways. First, let us solve it using the Schrodinger equation. Given psi of x equal to a e raised to minus b square x square by 2. And it is given that the wave function is normalized. Now let us write the Schrodinger equation. Minus h bar square by 2m d square psi by dx square plus v of x into psi of x, which is nothing but e into psi of x. Now substitute the value psi of x in equation number 1 so that we will get the potential or energy eigenvalue. Since psi is equal to a e raised to minus b square x square by 2, the first derivative of psi, that is d psi by dx, which is nothing but minus a b square x e raised to minus b square x square by 2. Now let us rearrange the term. We can write it as minus b square x a e raised to minus b square x square by 2, which is nothing but minus b square x into psi, because psi is equal to a e raised to minus b square x square by 2. Now you take the second derivative, that is minus b square x d psi by dx plus psi, that is minus b square x into d psi by dx is minus b square x psi, which we already proved. So the second derivative of psi becomes minus b square x minus b square x psi, then again minus b square psi, which is equal to b square into b square x square minus 1 into psi. We can write it like that. Let it be our equation number 2. Now put the value of d square psi by dx square from equation 2 in 1. We will get minus h bar square by 2m into b square x square minus 1 into psi plus v of x into psi of x, that is e into psi. Now psi is common, so you can eliminate psi. The remaining term is minus h cross square by 2m. The first term is b raised to 4 x square. The second term is minus b square plus v of x, that is equal to e. Let it be our equation number 3. Now you apply the boundary condition. It is given that at x equal to 0, the potential is 0. At x equal to 0, the potential is 0. Hence equation 3 becomes minus h bar square by 2m into minus b square, that is equal to e, or e is equal to h bar square b square by 2m. In our option C and D, which gives the energy eigenvalue, but our option C and D does not satisfy our solution. So we can say that C and D are incorrect. C and D are incorrect. Now to find out the potential, substitute the value of E from equation 4 in 3. Now substituting 4 in 3 gives minus h bar square by 2m b raised to 4 x square plus h bar square b square by 2m plus v of x, that is equal to h bar square b square by 2m. This h bar square b square by 2m cancel, and the final expression for v of x is h bar square b raised to 4 x square by 2m. Now let us go through our solution, our options. We can see that option B matches with our solution. So we can say option A is incorrect and option B, which is the correct option. This is the general method to solve these kind of problems.